Advancing Computational Linguistics. Breakthroughs in Language AI. This episode synthesizes 18 papers published on May 10, 2025, exploring cutting-edge research in computational linguistics. The focus lies on three critical areas: improving model efficiency, ensuring alignment with human values, and enhancing real-world applications. Key themes emerging from these studies include innovations in model architectures, refined evaluation methodologies, advances in multimodal processing, and strengthened safety protocols. Together, these papers demonstrate how the field is moving beyond theoretical benchmarks to solve practical challenges in language AI. Field Overview. Computational Linguistics in 2025. The discipline continues to merge insights from computer science, linguistics, and cognitive psychology to teach machines human language nuances. A significant shift has occurred from merely pursuing accuracy scores to prioritizing robustness and safety in real-world deployments. Recent innovations show increasing specialization, with tailored solutions for tasks like speaker identification and automated policy analysis. As AI systems become integrated into high-stakes domains such as healthcare, law, and education, these advancements in computational linguistics carry profound implications for reliability and ethical implementation. Research Theme 1. Model Architectures. The first major theme focuses on smarter designs for efficiency and performance. Chu and colleagues demonstrate this through their work on gated attention mechanisms, which significantly reduce computational waste in transformer models. Their approach introduces dynamic controls for processing long texts, with sigmoid gates proving particularly effective. These architectural improvements enable models to handle book-length documents without crashing while maintaining coherence in specialized contexts like legal and medical applications. Research Theme 2. Evaluation beyond leaderboards. The second theme challenges conventional assessment methods. Wang's team developed the feedbacker system, which profiles models like a coach to identify weaknesses in reasoning and bias detection. This approach recognizes that static benchmarks often miss critical nuances in real-world performance. Such advanced evaluation techniques align particularly well with emerging needs in automated policy auditing and other applications where understanding model limitations is as important as measuring raw performance. Research Theme 3. Multimodal Processing. The third major theme addresses gaps in speech and text AI integration. Peng's TS Superb benchmark provides a unified framework for evaluating target speaker extraction capabilities. This work is particularly vital for applications like hearing aids and security systems, where isolating specific voices from background noise is essential. The research demonstrates how self-supervised encoders can simultaneously improve both speaker identification and content extraction, bridging the divide between laboratory performance and real-world conditions. Key findings across studies. Several groundbreaking discoveries emerge from these papers. Chu's work shows how small architectural modifications can yield disproportionately large impacts on model efficiency. Curran's research reveals GPT-4's capability to detect geopolitical biases in policy documents, with significant implications for automated analysis. Meanwhile, Kim's team achieves breakthroughs in reference-free retrieval, enhancing conversational AI adaptability. Collectively, these findings demonstrate that innovation in computational linguistics increasingly comes from smarter design rather than simply scaling model size. Methodology synthesis. The papers share several common technical approaches. Many employ large language models as specialized classifiers, as seen in Curran's policy analysis work, though this requires meticulous prompt engineering. Reinforcement learning from human feedback emerges as another prevalent technique, though scaling it remains computationally expensive. Hierarchical processing systems like LIM's MAC-RAG demonstrate how breaking documents into multi-scaled chunks can improve performance, albeit with trade-offs in processing speed. These methodologies collectively highlight how hybrid systems combining neural networks with rule-based logic often outperform pure end-to-end approaches. Selected Paper 1. Chu et al.'s Gated Attention. This groundbreaking study tested 30 variants of attention gates across models up to 15 billion parameters. The most effective design applied a sigmoid gate after the softmax operation, significantly reducing redundant computations. Trained on an unprecedented 3.5 trillion tokens, this approach allows models to process book-length texts without crashing while supporting higher learning rates. The implications are far-reaching, potentially reducing the carbon footprint of large language models while improving their performance in specialized domains requiring long context understanding. Selected Paper 2. Curran et al.'s Policy Analysis. This research demonstrates AI's growing role in social science through automated analysis of 109 e-cigarette policy documents. The study revealed striking cultural biases in policy framing between countries, with Australia emphasizing risks while the UK focused on harm reduction. Achieving a 0.9 F score that matches human annotators, the work proves large language models' potential for policy auditing. However, the authors caution against overgeneralization, noting that performance may degrade for niche policy areas without domain-specific retraining. Selected Paper 3. Peng et al.'s TS Superb Benchmark. This work addresses a critical blind spot in speech AI by creating a unified evaluation framework for target speaker extraction. The benchmark reveals how models that excel in clean audio conditions often fail in real-world cacophonous environments. Peng's solution involves a self-supervised encoder jointly trained for speaker identification and content extraction. This advancement paves the way for next-generation hearing aids and security systems that can isolate specific voices from background noise, highlighting the gap between laboratory performance and practical deployment scenarios. Future directions. Several challenges remain unresolved in computational linguistics. Scalability concerns persist, with techniques like MAC-RAG demanding substantial computational resources. Generalizability limitations mean models often struggle when applied to new domains without retraining. Safety considerations become more complex as multimodal models may inherit risks from their unimodal components. Research priorities should focus on developing lightweight architectures, creating cross-domain benchmarks, and establishing safety frameworks that evolve with models. Promising avenues include intermediate representations like Cotterwas, thought vectors, which could help bridge the gap between specialized and general AI systems. Conclusion. The May 2025 papers mark a significant evolution in computational linguistics, shifting focus from metrics to tangible problem-solving. Three key takeaways emerge. Innovation thrives at interdisciplinary intersections, evaluation methods must evolve to capture real-world utility, and safety requires continuous attention rather than one-time solutions. As exemplified by the work of Chu, Curran, and Peng, the future of language AI lies not just in understanding words, but in understanding human contexts, biases, and needs. AI synthesis and review. This presentation was generated using GPT DeepSeek model, deepseek-chat, with TTS synthesis via Google and image generation via Google. While human experts reviewed the content for accuracy and coherence, potential oversights may exist despite these quality control measures. The synthesis aims to faithfully represent the original research while optimizing for clarity and accessibility. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.